Good morning. I hope you're doing well. I'm doing very well. There have been a lot of very interesting developments that have happened since the last stream 2 weeks ago, and I'm very excited to share it with you. Yeah, there's a lot to cover. There are a bunch of little things that I have left until the end. I think that will just like work more nicely with the flow that I want this session to take. But first, we have a bunch of like software updates from 2 weeks ago, which is I'm very, very happy with how things are going. It's definitely a bit of a learning curve, but that's good. That's good. That's how we get better. Cool. So the first thing is something that someone mentioned in the last stream, which I believe it might have been Yoroka. It was one of the people who have suggested a couple of things so far. I apologize for forgetting who it was. I should have checked before this. But in any event, someone suggested that I can change the way that the Teensy is being powered. So the reason why this is important is because we have power coming over the CAN bus, which goes to the 7 ODrives, as well as to a Teensy. And I want to use this Teensy to remember some things about what happened in each session, so that way in future sessions we don't need to do things that have already been done and that the ODrives remember having been done. I'll try to remember to get a bit more into that later, but for now that's what is going on. But there was a problem that I mentioned in the last stream, which was that the way that it was set up before, the Teensy was getting power from the CAN bus as well as from the USB connection. So if I had the Teensy connected to my computer, like let's say I was updating the firmware on the Teensy and I needed to make some changes, then the Teensy will be plugged into my computer as well as receiving power from the CAN bus. And this means that in theory, it could have happened. It didn't actually happen. Like this never actually occurred, but it could have happened where I powered everything off. The ODrives forgot everything about their previous state, but the Teensy remembered because the Teensy was continuously being powered by my PC. And that, I don't know, it probably wouldn't, no, I don't think anything bad would have actually happened, but there would have been some strange errors coming up and it would be desirable to not have that happen. I really want the Teensy to be as closely in sync to the ODrives as is physically possible. I want the Teensy to remember only things that the ODrives have actually gone through. Yes, and so it turns out you're actually supposed to do this. If you're powering the Teensy from some other external source, you're actually supposed to separate there are these little pads on the back of the Teensy that essentially separate the power coming from the USB to go to the Teensy. Like it just ignores that power line. And yeah, I guess I should have read the docs a little bit more closely, but in any event, I've done this now. Thankfully, this was so lucky because this Teensy is like soldered onto a piece of Veriboard and is like very attached on there. There's no way I'm going to get that off easily, at least. But thankfully, that pad, although those two pads are like right on the edge of the Teensy, so I could get my little like lobotomy screw thing and just like get in there and like scrape it out. It was very, very lucky that that was the case. Honestly, when I first saw that and I realized that the pad was underneath the Teensy, I was like, oh shit, like I'm not gonna be able to do this. This is it. But like, so good. It's just on the edge. Very, very lucky. Yeah, so now the Teensy is only getting power from the CAN bus. And this is, yeah, it's in my mind, so a couple of people have expressed concern about the way that I am doing this whole process, where before, the way that this works now, I won't talk about before, but the way that it works now is that the only thing that the Teensy is remembering is whether or not the robot has been homed. Because when I run through my homing sequence, that sequence is very different to what the ODrives have set up for their own homing sequence. Like there are a bunch of like homing pipelines that you can go through with that have like ODrive has like set up, so you can be like, tell the ODrive to home and it will run its own little internal homing sequence. But I'm not using any of those because they require external switches and that sort of stuff, which I really don't want to have to retroactively add onto the actuators. My homing sequence is current based, so it will run down until it hits a set current limit and then it knows that it's homed. Unfortunately, ODrive has not implemented anything like that yet. Maybe they will eventually. I haven't heard anything about it, but who knows? But for the time being, that homing sequence is completely run on my code. And I don't know of any way of telling, of like, if I was handed an ODrive and it was like on and still powered and everything, I don't know of any way to inspect that ODrive to tell whether or not it has been homed using my sequence. I don't think that exists. There is one thing that I can't remember the name of. There's like some variable that is supposed to be not a number until you like until you say, hey, you are now here. But that doesn't work for me. I don't know. There's information in Zulip. I'll put a link in the description to this, to that message in Zulip where I actually describe this in a bit more detail. But that doesn't work. So the only way that I have of knowing whether or not the system has been homed is having the Teensy remember if it's been homed. And I feel pretty okay with this. Like, there is a risk that that one of the ODrives forgets somehow that it has been homed, and the Teensy remembers correctly or otherwise that it has been homed. So the ODrive says, no, I haven't been homed, or if it actually hasn't, and then the Teensy says, yes, we have been homed. That could be a problem, because then the homed position of that ODrive would be wrong, and then that leg will be like off doing its own thing. But I feel like this is extremely unlikely to happen. Mostly because all of the ODrives and the Teensy are connected as a big daisy chain along the CAN bus. And this means that if there's any, and the Teensy is importantly right at the very end. It is the last component on this daisy chain. So in my mind, this means that if there's any kind of like electrical disturbance or like power fluctuation somehow, and one of the ODrives or more loses power, then everything from that point onwards would also lose power. And as far as I can tell, losing power is the only thing that would cause the ODrives to forget their like set homed position. So I think it should be fine. I don't know. I haven't had any issues yet. And I've tested it probably like 20 times, which I understand is not a huge amount, but like, I don't know. It seems robust to me. Obviously, it would be better to know, like to have the ODrives tell us whether or not they've been homed, but I don't know of any way to do that. So this is what we've got for now. But it is very good that the Teensy and the ODrives are now in sync. This is very nice. Okay, so the reason why I didn't want to talk about what I was doing before is because previously I had the Teensy also remembering whether the encoder search process has been done. And this is something that we can actually ask from the ODrives. So now, when the system boots up, the state machine will ask the ODrives, hey, have you done your encoder search or not? And there is a variable in the ODrives that will tell us whether or not they've done that. And so we can just poll that variable and say, hey, has this been done? Yes or no? And if it has, then great. If it hasn't, then we at least know that we need to run it. So that's very good. I like that this part doesn't rely on the Teensy. But yeah, I think it would still be equally robust if we had to do that as well. But it's nice to be able to actually get like the ground truth from the ODrives themselves. And so not only that, but the actual search process is now more robust. Previously, I don't know if I really went into much detail on this before. There's a lot of like, I mean, there's a few times in this stream where I describe these sorts of things, but in general, I think there's a lot of like very little things that I just haven't really been mentioning about this, like dodgy things that have been happening in the project. I think there's 3 in this stream alone that I will talk about, but yeah, previously the way that I was doing the encoder search is I was basically say, ODrives, do your encoder search. I send the request out to have that process be run, and then I just assume that it worked, because it always works. Like it never doesn't work, in my experience. And I would basically say, yep, go out, do it. And then once all of that code finished running, I'd say, yep, cool, it finished successfully, without actually checking if it did or not. And then we would continue off to do other things. I'm fairly sure I never had any issues as a result of this, because it is a very robust, like it just has to move the legs just a little bit. Like it's a pretty straightforward process. But I have improved this reliability quite a lot, so that now we check whether or not each ODrive has actually entered the encoder search state. So this is the state when it's looking for that index pulse. And then after we've confirmed, yes, at some point in like the last couple seconds, each ODrive has entered the encoder search state, then we check whether or not like trajectory done is true. And trajectory done being true indicates that the encoder search has complete. And then once we know that that's true, then we can say, yep, cool, we succeeded, off we go, let's continue. But if there are any issues in that process, I don't know what sort of issues could occur, but like maybe there's a power problem, or I don't know, who knows what, something has gone wrong, then now we actually get the feedback of saying, oh yeah, something actually went wrong, and now we can report an error. And that gets sent up the chain, up to the state machine. Much nicer. Now we actually know whether or not this is done. Yeah, very nice. Cool. Next thing is I have improved some error handling. And yeah, so a big kind of like big picture view of part of what I was aiming to do here is that I really want the state machine to be the ground truth of what state the robot is in. Nothing else should be able to say, hey, I think we're in this state. I think we're in this state, because that's just going to be chaos. I really want the state machine to be the only thing that is broadcasting that information of what state the robot is in. And before I had a field in my state machine topic, which I'm actually considering maybe getting rid of entirely, the entire topic, but that's a conversation for later. I previously had a field in this topic for like errors, and any errors would get sent across that topic from any of the other nodes, and then they would get received by the state machine and then processed. I've changed things around a little bit now, so now I have a separate bespoke topic just for state errors, and now this is all handled a little bit differently. And yeah, I feel like it's quite robust, but something that's kind of making me feel a little bit unnerved is the fact that I've had to modify the YASMIN state machine library itself to add some error handling procedures that it didn't have before. And I don't know, I feel very uncomfortable changing the code in that library, just because like people who presumably know what they're doing have made that. And I don't know, if I make changes, it might have implications that I'm not aware of, but it seems to be working so far. Yeah, so I've added the link to the commit in the description here, so if you want to check it out. And the way that this error handling works is if an error is detected on the hardware, like let's say there's a power issue or one of the legs has like freaked out and it's, I don't know, not misbehaving. When that error is detected, which that process is very reliable, when that error is detected, it's published to robot state error. This is then detected by a part of the state machine, which then updates the blackboard on the state machine. That whatever state we're in now is then informed of the fact that we have an error. And then we have a method in each state that's called like on error. And this means that what this allows us to do is it currently has a default error of just like error, but we can customize for each state, for each error, how we want to proceed. So this means that if there's if there's a very specific type of error where, I don't know, we want the robot to, rather than just like stop what it's doing and like go into idle, we might want the robot to try to correct into a less potentially destructive position before shutting off all the motors. Maybe. I've been umming and ahhing about this a lot, but at least now we have the ability to do this. So maybe there are even certain states where we actually don't care about certain errors. We might say, yeah, there's an error here, but like, that's not really worth going to fault for. Like, we can stay in the state that we're in now with this error, it's fine, as long as the error is handled before we go off somewhere else. Like, this is now a possibility. And yeah, I'm super happy with this. I really like how this is being handled. However, there is a question of whether we can change this step of publishing to robot state error. And this was a suggestion made by John, and I think it's a very good suggestion, but I'm really trying to give it a lot of thought because it involves changing quite a bit about how I've set up my code right now. So right now, I have a separate topic for each property of the motors. So there's a topic for the leg lengths, like the lengths that we are commanding the legs to go to. There's a topic for the actual motor positions. There's one for the motor velocities. There's one for the currents in the motors, etc., etc. And so each of these topics will have 7 elements, one for each motor. And yeah, so if I want to know where are all the motors? I can subscribe to motor positions and I'll have a nice little updating list of where all of the motors are. What John's suggestion is to have one topic, but with 7 ODrive state fields, where each of these fields will have, for each individual motor, it'll have the motor position, the velocity, the current, the state, the error, and whatever else we want to include in there. And this means that rather than asking where are all the motors, we can say what is happening with motor 1? What is happening with motor 3? What is like the exact state that that entire motor is in? And I really like this idea, but because I've got everything set up on a like per information type basis rather than a per motor basis, it's going to involve changing quite a lot. And I really want to make sure that this is well thought out before I start making those changes, because I'm expecting those changes to be rather painful and yeah, not fun to do. So my biggest question here is, how do we publish this? Because right now, the way that I'm doing the motor positions, for example, is I'm waiting for all 7 motors to update their position from the last time. And then once all 7 are in, then I will publish all 7 as a batch in one go. And usually they all come in within very close succession of one another, and then I publish them all together. And it's like pretty much real time. With this new, if we do go for this like state approach, these things will not necessarily be updating at the same time. Like the position is going to be updating way, way, way more often than the state, because the state only changes when we're entering or exiting like closed loop control or the encoder search or whatever. Like that occurs very infrequently. But the position is going to be updating at 100 plus hertz. And this introduces a problem, because in ROS, when you publish a message to a topic, any fields that you don't explicitly prescribe a value to will default to their default value. So if it's like an int, then it will default to 0. If it's a Boolean, I think it defaults to false. It has a default, and it will just default to that. And this means that if we try to publish things as they're coming in, so if we say, oh, cool, we've gotten a new position for motor 0, let's send that off as the position in the state, then all of the other values in that state are going to be nullified, basically, just like return to 0. And I don't know how to handle this. So in my mind, there's 2 options. One, at least 2, I guess. One is to just do that. And then on the receiving end, if we have any values that are the defaults, we just ignore them. There's a problem with that, which is that if we do in fact want to send a value that is actually the default value, like if the position is at 0, then that's just going to get ignored. So that's not really ideal. I mean, it's very rare that it's going to be actually 0.0, like nothing, but it's possible. And that's like a true value that's going to be ignored. Or we can do the same sort of thing that I was doing before, where we wait for all of the similar frequency data to come in and then publish them all as a batch. Or actually, just thinking about it now, there's a third option. It's almost certainly more as well. But the third option, which is probably my favorite, would be to, every time we receive a piece of information, we check what the last state was, and then we only update the thing that has changed. And then we publish the exact same message that we had before with the new updated field as an updated field. Like we leave everything else unchanged. And I think this seems like it solves the most problems in my mind, but it feels like it's going to be the most computationally intensive. Like if I have to have this code remembering the state of every single axis, and just like continuously updating them and like overriding parts of it and then like populating the message with the old contents, that feels a lot more computationally intensive. So I don't know. I really, really like this idea, and I've been dreaming for a while of having in the GUI that we use to control Jugglebot, I've been dreaming of having like a nice little panel of like, you can see exactly what's going on with all of the motors. Like you can see the positions, you can see any errors that are on them. They've got like little green indicator lights if they're all happy. It's like I don't know, orange if it's like in idle or something. Like I think that could look really nice. And this is an exact, like this leads perfectly into that. Before, the way that I had things would make it kind of difficult to create that panel because we'd have to be pulling information from all of these different topics. But now this will just be one single topic that has all of this information ready to go. So yeah, I really like it, but I'm unsure of the implementation. Yes. Cool. We have movement. Demo time. Enough talking, more doing. So let's go to this view. This white square will open up with the state machine once I open things up. All right. So I have unplugged the CAN cable and re-plugged it in. So this is a fresh session. Everything has been perfectly rebooted. Let me power it on and start up the robot. So we should see it runs through, it starts off in boot, goes through pre-op check, which used to be idle, but after some suggestions, I've changed that away from idle because it's not actually idling doing nothing. It is instead checking before we start the operation. So it is the pre-operation check. And I don't like the way that this is being presented here with all of these, like, so much text everywhere. But the general sequence here is we open up in boot, and in boot we check what happened in the last session. In this case, there was no last session, so nothing happened. But in other cases, it might be, oh, we've already homed, and we can tell that by polling the ODrives. Or if we've gone even, and like if we have already done the encoder search sequence, then I think I might have misspoken before. We check if we've done the encoder search sequence, which we can poll the ODrives for. If we have in fact done the encoder search sequence, then we will ask the Teensy, have we been homed yet? And if we've done that, then we say, yep, cool, okay, we know exactly what happened before. Once we collect that information together, we head off to the pre-op check, and then the pre-op check says, okay, what was our state before that we just received from boot? And then depending on what that state is, if we have not done the encoder search, then we do it. And then after doing the encoder search, we home, and then after homing, we go to standby. If we have done the encoder search, but we haven't homed, then we just go straight to homing, and then we go to standby. Like, it's a very, very robust system. And the best thing of all is something that I didn't even show you. Let me reboot this. I'm gonna need to unplug the cable. I spent a long time on this, and I really want to show you, so just give me one sec. Alright, so I just unplugged the cable and plugged it back in, so now we have a fresh session again. And let's boot it back up. And I'm going to need the e-stop close by, because let's say I'm starting the process and I go, ooh, crap, I need to turn the power off because I didn't see something and it's, I don't know, something bad is happening. I can hit the e-stop. I don't like this open small every time. I can hit the e-stop and we go straight to fault. And then I go, okay, cool, whatever the error was, I've corrected it now. Let's continue our process. Oh, I've changed something and it broke. That's embarrassing. Okay, I need to revisit this then, it turns out. I've been changing some other things and this must have affected this in a way that I didn't expect. This is the problem with live demos. Okay, so what this was supposed to do, and it did do before I changed things around, is if I hit the e-stop at any point as many times as I like, the system would go, oh, I'm like, if let's say it was in the process of doing the encoder search. So they go around one at a time and they do their encoder search. And if I hit the e-stop during that process will not complete and we will get an error. And then that will go up to the state machine and we'll say, ooh, we've got an error. We need to head to fault. And then we're in fault, and then I can correct whatever the error is. I can undo the e-stop so we have power again. It should, I need to check this again, but previously it was able to recognize, okay, the errors have all been cleared. We can continue again with whatever process we were in before. So if encoder search did not complete, then we redo the encoder search. If homing didn't complete, then we redo homing, and then we resume through the process. And I really kind of pushed this. I honestly kind of felt like I might be damaging like the power supply by how quickly I was hitting the e-stop. So I eased off a little bit towards the end, but there were times where I must have hit the e-stop probably like 7 or 8 times during this initialization process, and it like resumed correctly every single time. It was great. I just need to have a little bit of a look at how I'm handling these errors right now. Yeah. So let me unplug the can thing again. Okay, so we've got a fresh session again, and I will not abuse it this time, so I can show you the rest of the stuff that I've done. Cool. So we do the encoder search, and we home, and we are good to go. We are in standby. And now to get out of standby, so in standby it's just waiting there, the motors are all in idle, it's just kind of chilling. To get out of standby, I can send a message to a topic called the standby topic, and with this topic I can command what type of control I want to enter into. Right now I only have space mouse control, so if let me return you back to this view so you can see what's going on. If I enter into space mouse control, then we are now in active, where the robot is able to move around, and I can control it once again with the space mouse. Woohoo! I love this. It's so much fun. Even though I've done this so much already, it's still so much fun. And so we are now in active. If, let's say that there were other ways of controlling the robot, like a juggling method, which we will get soon, hopefully. Not hopefully, we will soon. If we want to enter into a different type of control, the way that I am anticipating this happening is that we first return back to standby and then go out of standby into the new type of active. I think, or I'm kind of thinking we might just be able to go straight from one type of control into another type of control, because the way that I have set things up, I kind of have like 2 layers of like security here, where in each individual node that is responsible for the controls, like the space mouse handler in this case, it will look at what type of control mode we are currently in, and it will say, am I that control mode? Am I the one that should be used right now? If that's the case, then it says cool. Then it continues, and in the space mouse control case, it will it will read the data from the space mouse and convert that into what it needs to be converted to, and then publish it out. If it is not the type of control that is currently being asked for, then it doesn't do anything. It just sits there and just does nothing at all. That's the first layer of I don't know, checking, of like confirming that only the correct node is like spitting out information. The second layer of control is that in the topic that is publishing the desired pose of the robot, I've included a field in there for the publisher. So each node that will publish this like command of we want the platform to go here, when it publishes that command, it will also say, it'll give like a little signature saying this was published by Space Mouse Handler. And then in the node that is responsible for then interpreting that data and then forwarding it on down the line so we can actually control the motors, that node will say where should we be getting control information from right now? Are we currently in Space Mouse control mode, or are we in some other mode? If we are in Space Mouse control mode, then all of the pose commands with the signature love heart from Space Mouse Handler, all of these ones will be accepted and they will be interpreted. All of the other ones, if they've somehow gotten through that first layer of defense that I described before, then they'll just be ignored. So I feel kind of good about this. I'm not sure if it's necessary to go back to standby and then back into active again. I really want to try to minimize the amount of like interaction that I have to do with the robot. I don't want to have to manually tell it, okay, I'm done with Space Mouse control, now I want you to juggle. Perform for me, monkey. I don't want to have to go back to, I don't want to have to tell it, go to standby and now juggle. I want to just be able to tell it, juggle from where you are. So yeah, I mean, I could automate that process, but yeah, I don't know. We'll see what happens once I add in additional ways of controlling it. But for now, I just have Space Mouse control. So we are still in Space Mouse control and I can move it around. I can exit by, I have a topic called return to standby topic. It's very descriptive. And if I publish to that, and if the message actually gets sent through, now I can do whatever I want with the Space Mouse and doesn't do anything. The robot is not responsive. It's in idle. So I can move it around to wherever I want. And then if we return back into Space Mouse mode, and you can see we're in standby in the state machine. Once we return to Space Mouse mode, we are active again, and now Space Mouse is responsible. Yep. And there are, so to let you in on some little secrets, bad secrets, they are secrets that should not exist. Little dodgy things that I've done, or haven't done rather. Right now, whenever we enter or exit from active, when we enter active, it puts all of the motors into closed loop control, depending on what type of control we're entering into. This is something that I quite like as well. So now, when I'm going into Space Mouse control, we don't make the hand motor active because it doesn't need to be controlled. The Space Mouse has no way of controlling that hand motor, so it's just still in idle. But in different types of control modes, like if we are juggling, then it will put all of them into active, which is very cool. Or closed loop control, rather. But yes, right now, as soon as we go into active, it just puts them into closed loop control, and then it starts receiving, right for the Space Mouse, it starts receiving Space Mouse data, and then it will go into the middle position, which is where, like, the resting position is. But when we go out of active, it just puts all of the motors into idle, just straight away. So if I put it in some, like, really wacky position, hopefully not too wacky, and then if I exit Space Mouse control, it just, like, dies, basically. It's like, oh, I'm out of energy. And that can be potentially a bad thing. Like, if I move it over somewhere without really realizing and then put it out of Space Mouse control mode, then it will just, like, collapse on itself. So that's not ideal. So what I need to add is I know exactly how to do this. I have methods in the state machine for on enter and on exit, like to or from each state. And so what I'm thinking of doing is, in the active state, when we enter active, rather than just immediately giving control over to whatever the controlling node is, before we hand over control, we will gently raise the platform up into its middle position where it was before. And then when we exit the active state, we will gently return the platform back down into its, like, stowed state when it's down the bottom. So kind of roughly what that will look like is when we enter, it will come up like this. Right now it's only doing this because the Space Mouse is telling it to go there, and yeah, that's not ideal. And then when we exit, it will look roughly like this, where it will go down nicely, and then it will exit active, and then we can return to standby and do whatever else we want to do. I think that's a much better way to go. That way we guarantee that the robot is in, like, a nice controlled position before we cut off power. And yeah, I think that's very good. The way that I did that just then is just by powering it off, because we are done with the demo. So I've already got that sequences in, like that. I've already got that sequence done. Like I have a sequence for gently lowering it down, and then, yeah, before handing off control. But before, I was just using this, like, gently go down process for when we power off the robot. Now, instead of when it's on power off, now we want to do it in active, or from when we're exiting active. So I think that shouldn't be too hard to implement, but I only got this thing moving, like, what, 16 hours ago or so. So we're getting there, baby steps. Cool. All right. I hope you liked our demo. Yes, there are some improvements to be made, and this is what I was just describing. So when we enter, we should gently send the platform to the mid position. This actually gave me a bit of a spook when I first did this, because the acceleration limits were set, like, fairly high. And as soon as, and to be honest, I wasn't even sure how much code I needed to port over from the previous attempt to actually get the Space Mouse control to work. I couldn't exactly remember if there were more parts needed than what I already had. So I started this all up, and I was expecting the state machine to tell me I was inactive and for the robot to not actually move yet, because I thought that I was still missing at least one component. Turns out I wasn't, and because the accelerations were set super high, as soon as I went into Space Mouse control mode, the whole robot was just like, whoop, like really quickly. I was like, oh shit. I was not expecting that. I should have had my hand over the E-stop just in case. But it was fine. It just went up to its middle position, and it was ready to receive Space Mouse commands. But yeah, I definitely need to add this controlled entering and exiting of active. Yeah, this is another reason why I am a little bit hesitant to, or I don't know, why my current preference is to go straight from one active state into a different active state. So like space mouse control into juggling or into GUI, rather than going via standby. Because if we go via standby, then that means that the robot's going to have to go down and then go back up again before it enters the next type of control. So I don't know. All of these things may feel like very minor things, but they're not minor things. Oh, actually, this reminds me. We've got one more thing for the demo. So we just ran a session. We've done what we wanted to do. I might now go into the code and make some changes. Maybe I would add this on enter, on exit thing. Cool, okay. Let's see if it's made a difference. Obviously, I haven't actually made any changes to the code, but we boot it up and we see we go pretty much straight from boot into standby. In reality, we go from boot into pre-op check into standby, but the pre-op check process takes like 0 time at all. And because we've already homed and we've already done all this stuff, we can just go straight into space mouse control. So we've just booted it up and now we're moving around straight away. How good is that? No more homing. I did the wrong one. No more unnecessary homing, at least. And this, yeah, so this and what I was just describing about like not wanting to like have to make the robot go down and then back up again, they may feel like small things, and like having to home every single time. It's like, yeah, but the homing sequence only takes like 10 seconds maybe. It's like, is it that bad? Yes, it drives me crazy. If when I was doing the recording for the last video, I must have started Jugglebot definitely at least 100 times. And that means 100 times I was sitting here waiting for the encoder search and the homing to finish before I could actually test the code that I had changed. And that just drives me mad. If I really want to just like get a recording done, I don't want to be sitting here waiting for this process to happen every single time. And similar sort of thing with the through the active, I don't want to wait if I don't need to. Is my TLDR. Yeah, I'm impatient sometimes. Okay. So, that's all good. Yes, so now we are on to more future-oriented thoughts. The first of these is whether Ruckig will make a return. And so some long-time followers of this project may remember Ruckig from, I don't know, probably months ago now. Oh, sorry, I need a drink. Yeah, and Ruckig is basically a way to do trajectory calculations. So I can say, I am here, I want to be here, how do I get there? And Ruckig can calculate this. And I tried using this for the hand motor to get throwing working, and it just was not working. And to be honest, I actually don't really remember the errors. I feel like my programming ability is improving extremely quickly, and I really, I don't think I understood things super well when I was doing it back then. I mean, ChatGPT improving the way that it has helped so much, so much. But in any event, I think Ruckig can help us out a bit here. Because what we want to do, ultimately, when we're juggling, space mouse control is one thing, and that's like a bit of a fun gimmicky thing. But for actual juggling, we want to be able to set a target position, a target velocity, and a target time. And these, in my mind, there's only really 2 events that are important per throw. That is, when does the ball come in? At what position, at what time, with what velocity will the ball be meeting the hand? And so that everyone's kind of on the same page, the way that we are describing, setting when a catch is just like when the ball passes the catch plane. And I have some thoughts about how to adjust this to like compensate for bad throws or to allow for more timing in the catch. But the general outcome will be that the ball is ideally caught on the same plane every single time. What we're asking is, when does the ball pass through that plane? At what position will it pass through that plane? And what will its velocity be when it passes through that plane? And then similar on the other side, when we're throwing, where do we want to throw from? How much velocity do we want to throw with? And at what time do we want to throw? But we don't actually really care about what happens in between those 2 things. As long as we catch at the right time, place, and velocity, and throw with the right time, place, and velocity, we don't give a damn what happens in between. It could go straight there, it could go down, it could go up if it wants to. Like, it doesn't matter. We don't care. So, a big asterisk on that is that we don't care about what happens in between as long as none of the actuators go outside of their limits. So we obviously want to make sure that they're not being told to go like way too short or too long or anything like that. So we do have some constraints on this, but within those constraints, we don't care what it does. This has to be real time, obviously. For juggling to work, you have to know what's going on in real time. Like, this is pretty much a must. And so I'm thinking, if only there was some way that we can set a target state and have a trajectory be calculated in real time for us. And this is a screenshot from Ruckig. So it says, Ruckig generates trajectories on the fly, allowing robots and machines to react instantaneously, i.e. in real time, to sensor input. And so it calculates a trajectory to a target waypoint with position, velocity, and acceleration targets, starting from any initial state, limited by velocity, acceleration, and jerk constraints. So in here, I can put in the limits on how fast I want the actuators to move and how far I want them to move. I need to double check that it has position limiting. I'm fairly sure it does, but I need to double check it. And you can read the rest. The rest is not as important. But the point is that Ruckig is extremely fast and calculates things in real time and will do, as far as I'm aware, it will do exactly this for all 6 legs at the same time. And maybe we can even get this to do this same calculation for the hand as well. So we have all 7 trajectories being calculated at once in the same process. I really, really like this idea, and I very much hope that this works. I have lost my keyboard. That's all right. How do I... There we go. Okay. So, I have some concerns though, some potential concerns about whether or not this will work. Sorry, I'm just trying to fix up my Bluetooth so I get my keyboard back. Yeah, one of these potential concerns is I'm not too sure how to send these commands out from Ruckig to the robot. So anyone who's been closely following along may remember that the way that I have previously been controlling all of the leg actuators is by using so-called trapezoidal trajectory mode, where I can send a target position and they'll go there as fast as they can within their velocity and acceleration limits. But that's only setting the target position. And that doesn't do anything at all to keep all of the actuators in sync. They're all just kind of handled on their own. They're all just doing their own little thing, trying to get to their target positions as fast as they can. That's really bad. It's super... I mean, if you go back and watch if you have watched the most recent video that I did where the robot's juggling 2 in one hand, it's so janky. It's terrible. It's not good at all. It's not remotely smooth. And yeah, like the whole thing is just like... It's not good. We want much, much finer, more precise control. So I'm thinking we would use position control because that is ultimately what's going to be sent out. Well, one of the things that's going to be sent out of Ruckig is what position should all of the actuators be at each instance in time. But I don't know what mode to use here. So pass-through mode is where the ODrives say, I'm going to trust that you are telling me information that I can actually follow, and I'm just going to do what you say. If you want me to be here right now, I'm just going to go there right now as fast as I possibly can. Like, I'm not going to listen to any of your silly little limits. I'm just going to go. And this obviously has some potential issues where if I send an erroneous command telling the leg to like extend to triple its length, then it's just going to like tear itself apart. So that's a potential concern. But the other forms of control don't really seem, they're not as like tight as with pass-through control. They involve other sort of filtering. So I feel like pass-through control is the correct method to use, but I don't know exactly how much information we can send it. So here, when we're dealing in position control, we can send the position, obviously, is like the first thing that you want to be sending. And you can only send the position if you want to. But if you know what the velocity is going to be as well. And if you know how much torque you're expecting the motor to be outputting, you can give the ODrive this information as well, and it will adjust the way that it's controlling the motor to try to kind of like take those things into consideration as well. And that should, in theory, if your calculations of the velocity and the torque are correct, then that should give much tighter control over the actuator. However, we don't know what the forces on the actuators are going to be, so this makes it tricky. So I'm not sure exactly what to send as the feed-forward terms. And these are the velocity and the torque. So Ruckig calculates, as well as the positions at all of the little time steps, it also calculates velocity and acceleration and jerk as well, but we're not going to do anything with jerk. Yeah, so it calculates the velocity and acceleration. So I can obviously send the velocity as the velocity feed forward, but acceleration and torque are not exactly the same thing. So, and in my mind, there's two options here. The first is to either just ignore acceleration entirely and only send the position and the velocity feed forward, or we can maybe make some assumptions about how much force the legs are going to be outputting for a given acceleration. So yeah, we can basically say, like, if the leg is accelerating at 1 meter per second, it's probably going to be pushing 1/6 of the mass of the platform. And so we can then infer, okay, this is probably going to be this much force. But of course, that changes a lot based on where the platform is. Now, I'm aware that this is exactly where Jacobians come in. Well, one of the places where Jacobians can come in, I'm pretty sure. But I don't want to have to be doing those calculations for, okay, we are in this pose and this leg is moving with this acceleration, therefore how much torque is that actually, well, how much force is that going to be? And then converting that force into a torque. I really would like for this entire control loop to be running as fast as possible, up to around 500 hertz. And yeah, I don't want to be having to do that like Jacobian calculation for the entire robot at 500 hertz. Like, that just feels like it's going to be a big computational burden, and I don't know if it's worth it. Yeah, ultimately, I feel like the answer to a lot of these questions is just going to be like, try it and see what happens. But I prefer to get as close to the final result as possible before trying things, just in case things break, because I really don't want this robot to break. Yes, and the other thing is that I'm a little bit unsure about is that we will need very, very fast communications through the entire communications pipeline for so-called online control to work. And what this online control is it will allow Ruckig to take in the actual positions of the actuators and then use those actual positions to update its trajectory to make sure that we match the target state as closely as possible. So rather than saying, we are here, we want to go here, here's your trajectory, follow this and you'll get there, it instead says, we are here, we want to be here, follow this trajectory, and also, by the way, I'm going to keep an eye on you, and if you're like deviating a little bit during the process, I'm going to update this trajectory to like keep you a bit more on track. This is obviously what I would like to do. Like, having that online control would be so much better than offline control, where it's not listening to any of the feedback from the motors. But this is going to mean that we're going to have to be sending the feedback from the motors across the CAN bus back against the communications coming the other way. Of course, it's not really an issue like with electronics, but it's we would have to send the feedback from the actuators out over the CAN bus, over ROS, and then into Ruckig, where Ruckig will then take that on board and then update its trajectory and then send that back out over the exact same way, but in the other direction. And that feels like it's going to be a lot of information. So I don't know if that's going to be too much. I don't know what the limits are for like ROS, or, I mean, the CAN bus I have a vague idea, but I don't know what, I've got some strange ROS issues, and I'll talk about these in a sec. And I feel like sending like 3,000 messages per second extra is going to just be a lot more for it to deal with. So I don't know. Ultimately, I think the answer is going to be just try it and see what happens. Okay, I need some more water. As I said, a lot has happened since 2 weeks ago. Okay, so changing pace a little bit. I have some thoughts on the approach that we are using to make Jugglebot juggle. As I said before, it was super janky earlier. Part of the reason for this jankiness, in my opinion, is that the platform was only responsible for the horizontal positioning, and the hand was only responsible for the throwing and catching, like for the vertical movement. I think that this separation is not good. I think that if we can integrate these two a bit more closely, then we can result, hopefully, in much, much, much smoother motion. And so my thinking of how this can work is that if the platform contributes to the catching and the throwing, even just a little bit, I think that that will go a long way to making this whole sequence much smoother. Like if you are juggling yourself, your whole arm will follow the path of the ball. Like it's not like your arm goes here and then you throw with your fingers and then you move over here and throw with your fingers. Like you really want to keep momentum going in the same sort of directions. And I think if the hand, if the platform moves down just even a little bit for the catch, it will be going in, it will be carrying the momentum of the platform down, and then it'll be ready to move across. And then if it contributes to the throw just a little bit, like a similar amount, then it will be moving up, ready to move across. And it will follow a bit more of a natural arcing pattern rather than just like the whereas like all this like stopping and starting is so much harder than just round smooth motions is the idea. But the question is how? And this is something that I have been scratching my head over for like literally years. I've had so much back and forth of how to have the 6-degree freedom Stewart platform work with the hand, which adds a 7th degree freedom. And this was always just driving me mad of like, okay, the ball has 6 degrees of freedom, but the robot has 7. How do we make that work? Maybe if I studied robotics properly, I would actually have an understanding of how this could work, but I didn't, so I don't. But I have a maybe idea, which is that we can have and this was very heavily inspired by the conversation that I had with Kai, the German PhD student or candidate, doing his PhD on a juggling robot. And I've got some clips from that conversation that I would like to show eventually, but not today. But in any event, one of the outcomes of that conversation is that I think we can have a variable that will set how much of the catch or throw velocity should be handled by the platform. And then we can take this velocity, so like that, let's say that that's really, really low, and it should be at the start, because the ball, when it's being thrown, is moving quite quickly, and the platform will not be able to do a very large amount of that motion, but it can do some, it can do just a little bit. And so I'm thinking if we can have a slider that says, okay, the platform is responsible for 10% or 5% of the throw and catch velocities, then, and maybe we can have a cap of like a maximum velocity that can hit, whatever it is, we can say that is the target velocity for the arm, for the platform, at that state. And then that target velocity is what is sent into Ruckig. If we go back, here, that is what this velocity is. So when we go to Ruckig and we say, I want you to be at this state, the velocity that we want the platform to be at is the outcome of saying we want you to take up 10% or whatever of the velocity of the ball coming in. Of course, that ball velocity is going to be on a slight angle, so this velocity will also have to take that into consideration. But yeah, that's my thinking. So one more possible concern or thought that I have regarding this is that when we calculate this target state and we say, okay, cool, the platform is taking up like 5% of the velocity of the ball, that's the platform. But when it comes to Ruckig, Ruckig doesn't care about the platform. It doesn't know about the platform existence. It only knows about the 6 or 7 actuators that it's responsible for controlling. So we need to have a step before we send this information to Ruckig where we say, okay, we want the platform to be here. This means that all of the legs need to be certain lengths to get the platform to be there. And that's fine for position, but I don't know if that's going to be fine for velocity. So if we say we want the platform to be here with this velocity, I don't think that there is going to be a linear relationship between platform velocity and leg velocities. Like some of the legs may not need to be moving at all. Some of them may need to be moving slowly at first and then quite quickly to make sure that that platform moves straight. And I don't really know how to handle that. Part of me is thinking that we can just kind of approximate it and assume that they will all be linear, at least at the start. But yeah, I don't know. I don't know what's going to happen there. It's a tricky problem. Okay. Now, that's the heavy stuff over. Now we've got some cool, fun things, which I'm very happy about. The first is that the CAN cable connector is fixed. You may remember, let me grab them. You may remember that I had certain issues arise as a result of using these. I've been calling them terminal screw terminals, or like terminal plugs. If these have a different name, I would love to know if they're called something other than terminal plugs. But I was using these connectors to wire the CAN bus into the robot. And like when you're holding them in your hand, they feel pretty solid. Like they're not, it takes a fair bit of force to pull that apart. But when they're in a big robot and they're not just in your little fingertips, things kind of change a little bit, and these are not solid at all. And if you've seen my last video, you may remember that at one point, just from the robot juggling, I mean, granted in its super janky sort of movements, it managed to wobble its little plug out and it lost communications, and there was a whole smoky issue. But now we will never have this problem again, because the connectors are solid. So let me, this is the second of the things. So I've fixed it on two ends. I only have photos of one of the ends. But I have changed both the connection to Jugglebot and also the connection to the Jetson, the Jugglebot computer. And so this is another one of those things that was a little bit sketchy that I don't think I ever actually showed. But it was very, very sketchy nonetheless. So this is what the Jetson side of things used to look like, where we had a 12-volt power line coming in from above. This is like the white heat shrinked part. I spliced in two cables, a black and a red cable, into that 12-volt power line. Then ran that around the side, cable tying it onto the side of my little Jetson case, just for good measure, for strain relief. And then we had the piddliest little like 20 gauge wire or something. Let me bring that back, sorry. Here to connect the CAN transceiver and the power cables into the same little screw terminal. And this literally every single time I moved the cable around and I saw all of these little cables flex and move around, I was like, oh my God, this is just like waiting for one of these cables to snap, or like one of these little screw plugs to come out of the CAN transceiver. And like that CAN transceiver is only barely, it's very tenuously held into the Jetson as well. Like the whole thing is just sketchy. So obviously I didn't really like that. Why are you doing that? Yeah, so that's a top view. Oh my God, stop going over there. Maybe if I make it full screen. Yeah, that's better. Cool. Okay, so this is, yeah, top view, side view. You can see my little, my cable tie. That's the CAN transceiver, showing a bit more detail. And now we have this. So after a lot of deliberation and people making some very good suggestions on different connectors that I can use, I did end up settling on the Deutsche connectors because I could actually find a kit of like a whole bunch of these in one big kit, and it's great and I love it. And for all the other ones, they were so expensive. Like this connector, each of these, I've got like 4 or 5 in here. Each of these were like 15 to like 20 bucks each for like, not even for the full connector, but like, how do these even separate? This was like 15 bucks and this was like 15 bucks. This whole thing was like 30 bucks. And for all of these as well. Too much money. So now I have bought a like $200 kit of Deutsch connectors, which have like shitloads of things in them. So I have enough for days. And these connectors are super solid. So yeah, this is what it looks like from above. And you can see I've also got this other little board here, which wasn't there before. And what that board is is it's a second CAN transceiver that basically listens to my CAN bus and will allow me to plug in a micro USB so that I can listen into the bus on a separate second computer. And this is something that I had done a little bit, like I've played around with this a little bit in the past and done a little bit of listening in, but every single time I was listening in, I would have to add in my dodgy little spliced terminal block thing and then plug my CAN transceiver into this and then plug that into my computer. But now it's here, ready to go. Anytime I want to listen in, I just plug the micro USB in and we're good to go. And yeah, so these cables, I've increased the gauge of the cables quite a lot because I felt very nervous about these super thin ones. And here's what you can see is on the inside. So something else that really irked me about this design here, with the earlier version, is that I could never move the Jetson without taking the power cable with it. This was such a dumb idea in hindsight. I don't know why I did this, but having the power cable, that 12-volt line, the one that's on the right, having that spliced in and then cable tied onto the side of the Jetson means that A, if I want to unplug the Jetson from that barrel jack, it's really hard to because the amount of tolerance there is like none. Like pulling that out, I would be pulling against the cable tied spliced cable, which is not good. And then B, if I want to do any work on the Jetson, like if I want to take it out and like put it on my desk or anything, I just can't because the power cable's not long enough to do that. So then I have to like unplug it from the wall and it's just a whole thing. But now you can see it's removed. The Jetson is by itself. And the way that this works is that everything has to be a little bit dodgy, right? It's just the way of the world. And the dodgy part in this one is how I've connected these power cables. I have a feeling this is definitely not NVIDIA approved, but I was really scratching my brain about how to get the 12-volt line from the input barrel jack out to the CAN bus, because I need this is the red and the black wires here. I need this red and black wire to provide power to the CAN bus so then the ODrives have power. But I'm like, do I add an external female barrel jack that I then route one of the outputs to the Jetson and then one of the outputs to the CAN bus? It's like, yeah, I can kind of do that, but then that means that the power is going to be coming in somewhere else. And I really like having all of these, I don't have a good photo of it, but all of the input-output connectors, like these USBs and the Ethernet and everything, they're all nicely framed in this housing that I've got. And I don't really want to have the barrel jack kind of separated from that. So the best thing that I could come up with was to just solder these cables directly onto the barrel jack before those power lines go into the Jetson. That was another thing that I wanted to avoid taking power from, like, as far as I'm aware, there actually isn't even a like power line anywhere else that I can kind of tap into. Like there's no GPIO port that has like a 12-volt or has like the V-in line. But even if there was, I didn't really want to be powering my entire CAN bus off of like a GPIO port. So I figured that this would be good because this means that at least if the CAN bus for whatever reason draws a fairly high current, that current won't be seen by the Jetson. It'll just go straight through this kind of dodgy little soldering that I've got straight through to the power supply, is my plan. And it's very hard to get a good photo of this, and this soldering was fairly tedious to do, but it seems like it's working, so we're good, I guess. And yeah, this brings joy to my heart. It's so nice. The only gripe that I have with it is the way that it's physically sitting on the ground. So if I move our camera around a bit, let me get rid of stuff we don't need. So here's the real deal. So you can see that the cable is currently coming out at a bit of a wacky angle. So we've got Jugglebot over here, and you can see that end. I've made a nice little housing for it. But underneath that housing is just another Deutsch connector. And then we follow this cable around. It's quite stiff, so it really wants to hold its shape. And then when it gets around to here, I can't zoom in any further, but that is a very not nice angle. And it doesn't get moved around too much, but I don't really like that all 4 of those cables are being angled like that. And I don't really know of a good way to fix that. So I don't know. If anyone's got any ideas, I'm very interested. Also, like, is there some way to like secure the cables that are coming out of the Deutsche plug a bit better. So what I mean by this is, let me go to here. Oops. Sorry, let me just bring this back up. Full screen, so it's going to spaz out. So here, this is like the cables are coming out of the Deutsche plug, and in this case it's fine for them to be all exposed because they don't need to be covered up. But like on the other end, on the male end that's being plugged into this, those 4 cables are just like exposed before they go into the why is that changing? Before they go into the Deutsche plug. So there's like 4 cables that are just kind of out by themselves. And I would really like if there's some way to like fix the, let me grab one. Should have just done this before. So this is what I'm talking about. Here, it's not as bad because I've made the heat shrink go like right up to the end. I don't want to pull that too much. I'll just grab this. All right, so this is the end that I was referring to. So here, these cables are just like out, and they're pretty strong cables, but like I feel like having this sort of dangliness is not good. I really want some way to like attach this Deutsche plug to this cable so that they're like one unit. But there's no features on this that will allow you to do that. And like, I don't know, is this how you normally leave Deutsche connectors? It feels wrong. I don't know. If anyone's got any experience with these, I am very interested to know. It's my first time using them. I'm a big fan. They're very nice. That's my kind of lingering question on them. Cool. It's first little thing. Finally. Yeah, that was a long time coming, and I'm glad that that's finally fixed. Second new thing is that the new balls arrived. Finally. Again. These balls are so weird. I don't know. Let me see if... So you can see there's sand in the ball, and this sand means that the ball behaves very weirdly. I have used these for one juggling session of my own so far, and I don't know if I like them. All of the reviews that I could see for this style of ball is called a Russian ball, and these in particular are Norwick's. I don't know if that brand will come up on the camera, but they're called Norwick. And yeah, every time I saw reviews for like Russian style balls, all of them were either like, you will love them or you will hate them. And right now, to be honest, I'm kind of leaning towards the latter. They're so weird to juggle with. They're really big and awkward to hold in one hand, but I think they will be amazing for Jugglebot. So part of the strangeness about these balls for me as a human is that, I don't know if this will come up really very well on the camera, but sometimes, especially when they get spun, when they're thrown, they wobble around in the air quite a lot, like a very noticeable amount. And that's very strange to witness. And yeah, they're just really weird to throw in my experience, but they are amazing to catch. If they just like land just on your fingertips, they'll just stay there. Like the way that they drop is such a dead drop because that weight is like, their center of mass is like here down the bottom. And because it's so low, it will just kill all movement as soon as it hits the ground. And this is obviously really good for Jugglebot. Like if I was doing some testing before with this like older version of the hand, which is obviously very small, I can just like toss that in fairly roughly and it will just like land there. But if I was to do that same sort of thing with a different ball, like it doesn't stay. It just goes everywhere. Not to mention the fact that these are actually lighter than like every other ball that I've got. Like this green ball is significantly lighter than the orange and white one, which I think is extra nice because it means that the hand motor will be having to do less work to move the balls around. So overall, I think these are fantastic for Jugglebot because for me as a human, they make throwing weird, but they make catching a bit easier. And I think that is exactly what we want for Jugglebot. For Jugglebot, throwing is going to be completely different than throwing as a human. Because when you throw as a human, you roll the ball off the end of your hand and it spins in the air. And that's what causes that weird rocking motion in the air with these balls. But for Jugglebot, if it's just doing like that, if it moved straight, like I can't even, I have such a natural like curve to my throw just because of the way that my arm is structured. But with Jugglebot, when it moves to throw, it should, I expect, be throwing extremely straight, and I think that the wobbling will be a lot less. And importantly, because these balls have such a dead landing, they make catching so much easier. And I think that that is going to really be where these excel for Jugglebot, is that we want, because we want catching to be as straightforward and as easy as possible for Jugglebot. So this means having a nice big open hand and balls that just kill their kinetic energy, and they'll just land in and just stop. So I think these will be really good, and I'm really keen to start using them for Jugglebot. And I'm so excited, in fact, that I actually, and also because the motion capture should be on its way. I haven't heard any updates, but we'll get there. In my excitement, I have bought some retroreflective tape in every color that I could find, just because I'm curious to see how they all perform. And I've already done one. I've wrapped one of the balls in this retroreflective tape. And so that looks kind of cool in the camera. But my problem is that this is really hard to wrap. This tape is a lot more stiff than I was expecting it to be. And like this tape is used for like putting it on like trucks and I don't know, anything that you want to like reflect. And I didn't expect it to be nearly as stiff as it is. And so I cut 15 strips to surround this ball with, and you can see that they don't quite wrap the ball perfectly. Like there's still, it's kind of like an armadillo shell. Like there's edges to catch on. And this was, it was very time consuming, and I don't know if I like that edge. It's very frustrating. Extra frustrating because the reason why I ended up going with 15 slots or like strips to cover the ball in is because in my conversation with Kai, he showed me his ball, and look at that. Look at how smooth that is. But I didn't really think about it in our conversation. I was like, oh yeah, cool, you just like wrapped it in tape and it worked. But I had no idea that this retroreflective tape is so stiff. And I'm kind of wondering, I've emailed him and asked, but he has, that was only last night. So we'll see when he replies. But I have a feeling that maybe his ball did look like this at one point, and now just over like hundreds and hundreds and thousands of throws and catches, it's just been like mushed down into like a nice smooth ball. The fact that there's all this like crinkling on here kind of suggests that to me. But I'm so like, that's gray. That is decidedly gray. But this is like white. So I don't know. Maybe it was just different tape. I don't know. There's one other kind of funny thing that I want to just mention on this topic with wrapping the ball, is that I discovered in this process that we don't have a compass at home at all. And so I'm like, oh shit, like I found a tutorial on how to like make the shape that you need to make to wrap the ball, to wrap a sphere. I'm like, oh, I don't have a compass. I don't want to like go to the store and buy a compass just for this. So I realized, haha, I have a modern day compass, kind of. And I ended up just modeling the strip in Onshape and printing it out. So now I've got this little printed strip, which feels wrong, but also it worked. So it's kind of good. Yeah, it's pretty funny. So, and I've also got in a link in the description to this video, I've got the model that I used to make this strip. And so if you ever have any ball wrapping needs and you need to know what shape you need to use to wrap the ball, then you can use that Onshape document, and you can set like the ball diameter and the number of strips that you want to use. Yeah. One final thought that I have on this is that if Kai's ball was in fact markedly different to this, and like if this actually does turn out to be an issue, like the fact that it's not smooth, then I'm thinking one other option could be, rather than covering the entire ball in retroreflective tape, we could, I mean, it would probably take a while, but we could cut out like a bunch of little tiny circles and then cover the ball in those dots of retroreflective tape. So rather than having like one big one, it'd be like 50 or something small ones, like a golf ball almost, but slightly bigger. And then the tracking system can pick up all of those things as separate dots, but it will be treating that group as a rigid body, which is something you can do in the motion capture software. You can say, hey, this group, this is a rigid body. These are all together. So I don't know. I do like this, but I don't know. The more I see it at a distance, the more I'm like, yeah, this is okay. But then the more I look at it up close, I'm like, no, it's not good. And actually, one final other thing on this topic is that in an effort to mold this down a little bit more and to try to like make it a bit more spherical, I tried heating this with my heat gun and then like squishing it down on the table to kind of like work it all down. But it's very easy to overheat it. And I don't know if this is really going to come up on camera, but this end part, like right here, is it's like bubbly. Maybe if I show the top. Yeah, you can kind of see, like if I show you, like this side is nice and smooth on the top, but this side is all rough and bubbly. So that's probably not good. So I kind of stopped after that point. I also don't know how much I want to be heating up these balls because they're sealed, and I think heating them up might make them pop. So I don't really want to do that too much. Yes. Okay. One other fairly minor thing is that I've updated the firmware on the ODrives to 0.6.10. I'm just kind of putting that in here because, I don't know, it's useful to be up to date. One strange thing is that the legs seem to need periodic recalibration. So I've always known that like industrial robots and this sort of stuff, you have to, every now and then you got to like go through and like run through a calibration sequence just to recalibrate everything and make sure that it works fine for like the next period of time. I never really thought of Jugglebot as being a robot like that. I've always just assumed like, yeah, I calibrate it once and nothing will change, so it can keep its calibration. But I don't think that's true now. I'm noticing that around every 3 months or so, I'm getting spin out errors from certain actuators. I should probably be keeping track of which ones it's happening to, but I haven't been. But every now and then I'll put the robot into closed loop control. And then if I even so much as like move fast near it or like lightly touch it, one of the actuators or more, depending on what happens, will enter spin out, will report a spin out error. So it's like if I basically move the motor just a smidgen, it will say, whoa, what's going on here? I don't like this. And it will freak out. And the only way that I have found the most reliable way that I've found to get rid of this is to go through that calibration process again. And then it seems to be fine after that. So yeah, I guess I just have to like set a timer every couple months, just like recalibrate all of the axes. Yeah, I'm surprised by this. I didn't expect this to need to happen. And I don't really know what causes it. Like, I'm not changing the actuators at all. Maybe over time, the encoders are just being bumped a little bit, or I don't know. Who knows? Okay. Almost final thing. This has been a long stream. This is what I was referring to before, where every now and then I have missing ROS messages. And this was happening on the last code implementation, but I just chalked it up to there were too many messages going over the ROS network and sometimes they're just being lost, and that's just how it is. But now that I've started building things back up again, it's starting to happen again. And I don't know why this is happening. And if anyone has experience in ROS and knows potential reasons why this could happen, I would love to know. My symptoms are that when for example, let me run you through the sequence that can lead to this. I turn Jugglebot on, it goes through its whole like boot sequence, it does all that. That all works fine every single time. And then when I go to manually send commands, like if I'm typing in the command line, like ROS2 topic pub, and if I hit enter, I send the message out, sometimes it just doesn't get received. It doesn't even seem to go out at all. Like if I have a separate separate shell window open that is echoing that topic, that shell doesn't indicate any reception of that message either. So it seems like I hit enter and the message just vanishes. It just doesn't even go out. And I really don't know why this is happening. So it's like earlier I was showing you when I enter space mouse control mode, I have to send a command to standby command topic. And I hit enter, that command goes out. It should instantly go into space mouse control mode. But sometimes I have to send that command like 3 or 4 times before the robot actually does what I want it to do. And it seems like this is only happening on commands that I send manually over the command line. I have never noticed it happen with commands that are automatically being sent by scripts, or if I have like the GUI open and I'm sending stuff over the GUI, that all seems to work fine. Like I don't recall ever having to click a button twice on the GUI to get the robot to do what I want. It only ever seems to be when I am sending it manually. So maybe there's some special way to set up the command line interface where I'm like sending these commands to be like, hey, let's increase the robustness of this message or something so that it sends out more properly. I don't know. it's weird and it's kind of annoying. So yeah, I'm all ears for potential reasons why this could be happening. This is something that it's like, because I don't know why this is happening, it feels like it's taking up a fairly large space in my brain of like, oh shit, like what if I do start increasing the amount of traffic over the ROS network because I'm sending all of the feedback from all the motors to Ruckig so that Ruckig can do our nice online control, but half those messages are just like entering the ether and never coming out. Like, yeah, I don't know. So many unknowns. The final thing for today is that I have my first nylon carbon fiber parts, and this is the third thing that sneaky little thing that I don't know if I've mentioned before, like at all in the project, but has been like very much on my mind for months, is that these parts are, I should have opened the Onshape model, but these, let me quickly open it up. This will only take a sec. So these parts are on the top of the legs, and they're part of the joint that attaches the leg to the platform. I don't even need to adjust my space mouse. Oh, this is so good. All right, so we have Jugglebot here, these parts here. Let me get rid of this, these guys. These are fairly important parts and fairly load-bearing parts as well, because they are cantilevered in a pretty crappy way. But that's the easiest way to do it kinematically that I could figure out. But in any event, these are here. And yeah, one of these, at least, potentially more, has cracked now. I think this is partially because this has a threaded insert in it. And the wall between the threaded insert and the edge of the part is very thin. Like that's 1.3 millimeters as measured in CAD. And it's so thin that when I actually add these threaded inserts, this one might show it better, that actually makes the edge bulge out. You can see that edge has bulged out where the threaded insert has gone in. And I don't know, that's where the crack happened in the other ones. But the other ones are PDJ, and these are now nylon carbon fiber, which is pretty cool. It's not red, which kind of irks me, but they should be super strong, much, much, much stronger. I could, of course, increase the thickness of this part, but that is very tricky because if I increase that thickness, then it's going to interfere with the actual operation of this joint. Like this needs to be able to move around very freely. Maybe I could increase the thickness of like just this edge part, but I don't know. In any event, I'm very keen to see how these new ones go. It was cool. I was very daunted about printing nylon carbon fiber because I've heard that it can be a bit tricky, but it was fine. I dehydrated my filament for like 24 hours beforehand, and these all turned out great. So now that those are all printed and ready to go, I'm thinking I am finally at a point where I'm happy to start gluing in these bearings. So this is probably the biggest mechanical issue that the robot has right now, is that these bearings that are inside, like if I hide these bearings in here, are not seated properly into this part that I just showed again. The amount of space in like this cutout is, for whatever reason, a little bit too big. And that means that these bearings can move around a little bit, and that's really not good. That's like, the whole robot has so much more wobble as a result of those bearings being a bit loose. So I'm thinking, probably next week, I will go through, take out all of the legs, and then replace all of these parts with the new nylon carbon fiber ones. And while I'm there, I can go through and glue all of these bearings in. My thought process for gluing them in is that I will put this shoulder bolt through, have both of the bearings like on the shoulder bolt. I'll probably put a nut, like the same sort of like washer on the end, a nut on the end of the shoulder bolt, and then have it all like really nice, expanded and loose, and then slide the bearings out, apply a very small amount of JB weld onto the outside of the bearings, slide them in carefully, very carefully, making sure that there's no glue that gets onto the inner race, and then tighten up that nut just to like hold it all nice and clamped in place. Hopefully that works. If you've got any suggestions about how to do that differently, I would love to know, because that's something that I will hopefully do next week. Now, this is obviously something that I've known about for a while, and I've been putting it off because for a while I was planning on like measuring all of the legs and seeing how long they actually are, and I wanted to do that process at the same time as like while everything was taken apart, I can like take all of my measurements, replace all the bits that I need to replace, and glue everything together. But now that motion capture is coming, I don't care to try this like measure the length of the actuators business. I'm just going to measure the whole robot with motion capture. So that whole side project is now just gone. I've bought my way out of it, which I love doing. It's so nice when you can just pay money and your problem disappears. Yeah, so now I feel ready to actually go through this whole, take it all apart, replace the parts, glue all the bearings in, and hopefully, big hopefully, a lot of the slop disappears. I'm very, very hopeful that that happens, because I don't really know what else will be causing slop. So yeah, we'll see. Cool. All right. That's everything. You're all caught up. I'm pretty sure. Yep. So lots to do, as always. I think next week will probably be the hardware updates that I just described, and definitely changing the like into and out of the active state in the state machine. That should be very quick to do, in theory. And then Ruckig. Ruckig is the next big one. I really want Ruckig to work. And my thinking is that rather than jumping straight into like juggling control with all 7 axes, I want to use Ruckig to take the space mouse control and then use Ruckig to actually move the robot from that. So right now, the space mouse control is working the exact same way that it was before, where it's all trapezoidal trajectory. So 100 times a second, we are taking data, taking the readings from where the space mouse is, and then sending that out, and then we're saying, all 6 actuators, go here as fast as you can. And then 1/100th of a second later, or like 10 milliseconds later, we're saying, now go here, now go here, now go here, now go here. And all of the actuators just try to go there as fast as they possibly can. And that works for space mouse control. It's nice and smooth and whatever. But it doesn't work for juggling control. So my goal is to have the space mouse control be as smooth, or even smoother, if possible, with Ruckig control before I start using Ruckig to do any sort of like juggling control. So yeah, 3 big things. I don't know if I'll get to all of them next week, but I think that I feel pretty good that I'll be able to do the hardware and the active state thing, and I'll fix up my error thing so that I can show you like punishing the robot, like hitting the E-stop all the time and it recovering, because it's so nice when that happens. There's just definitely some little bug in there that I haven't realized. And then hopefully I'll at least get a start on Ruckig, but we'll see how the week goes. Yep. Cool. Good stuff. Hope you found this interesting, as always. And yeah, as always, any thoughts? I am all ears. I'm very, yeah, as always, I very much appreciate when people have suggestions for things. It helps a lot knowing that I'm not just kind of running around in circles, even though sometimes I definitely am. Yeah, especially with this ball wrapping. I don't know. I really want this to be nice and smooth. But we'll see what Kai says. Maybe I just need to like sit there and like throw this into like a hand for like, I don't know, a month. To smoothen it out. Cool. Yep. Hope you found this interesting. Good luck with everything you're doing. And I believe I will see you next week. I didn't check my calendar before this. I'm pretty sure I have nothing on, so I'll probably see you next week. If not, I post updates in the community, the YouTube community thing. If I am not going to do a stream that I said that I would do, then I always post in there being like, hey, sorry, something came up and I can't do a stream this week. So if you are unsure if the stream is going to happen, you can check the community things. Although I don't like the way that YouTube handles that, so I don't know. You'll just see, I guess, in a week if I'm here. Cool. Have a good one.